I'd like to use our examples from the Lewis dot diagrams of molecules to help us learn a little bit about VSEPR shapes and how you are supposed to know what shape a central atom has. So here are 3 examples that we did with the Lewis dot diagrams, because that's where you start with the VSEPR shapes. You start by understanding these Lewis dot diagrams. So if you don't have a good solid foundation on the Lewis dot diagrams, VSEPR shapes become much harder. So pause this video, go back, practice those Lewis dot diagrams or you'll regret it. Okay, so if you look at the Lewis dot diagram after you've formed it, and maybe you're looking at the structural diagram just because it's neater, you're going to look at the central atom. That's the nitrogen. That's the one in the center. And you're looking at that central atom and you're thinking to yourself, it has 1, 2, 3 bonding sites and 1 lone pair. And you've hopefully copied that chart down from the notes package, if something has 3 bonding sites and 1 lone pair, it automatically has a trigonal, pyramidal shape. Okay, when it has a trigonal pyramidal shape, or you could just say pyramidal shape, what happens is this pair of lone pairs, which occupies a lot of space, is going to push down those bonding electrons. It repels the bonding electrons and it repels it downwards. So right now this picture has 3 sticks that kind of look like a T junction like this. That lone pair, which would be like my face, I guess, if this is the nitrogen, here's the lone pair, is going to repel these downward into a tripod. Okay, and so how do we draw a tripod on a piece of paper? When we're drawing a tripod on a piece of paper, you're going to notice that 1 stick goes directly to your left, another stick goes towards the camera, and a 3rd stick is coming towards my body. That tripod there is going to be converted into dashes and wedges. So this towards you is going to be a wedge. It gets small and goes bigger. And this that's going towards my body is going to be like an echo. It's going to have dashes. So we're going to redraw that trigonal pyramidal shape into a nitrogen with a stick, a wedge going towards, and a dash. Okay, and then sometimes that lone pair is still there and sometimes it's not. Just a matter of if I'm trying to communicate, there's my lone pairs and that's why it pushed it down. Those lone pairs aren't a necessity, they're just more of a description, so you can go with that. But do notice that this points downwards like a pyramid. That is correct. This is incorrect, because it just shows that you've memorized how many dashes and wedges, but you don't recognize the shape of that tripod. So this is wrong and this is right. Okay, let's try another one. If I'm looking at methanol, again, you're going to start by drawing the Lewis dot diagram, maybe having a look at the structural diagram, which would look like this: stick, 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 stick. Okay. Once you look at that, you have, pardon me, you have 2 central atoms here. You've got a carbon that's surrounded by other atoms, and you've got an oxygen that's surrounded by other atoms. There are 2 central atoms, so I'm going to give 2 VSEPR shapes for this answer. Let's just have a look at the carbon first. That carbon has 1, 2, 3, 4 bonding sites and no lone pairs. 4 bonding sites and no lone pairs means it's going to be tetrahedral. And then I'm going to look at the oxygen central atom. The oxygen has 2 bonding sites and 2 lone pairs. If something has 2 and 2, it is bent or V-shaped. Oops, not benda, but benta. So if it's bent, and then it's going to look like a V. You can call it V-shaped, you can call it bent. When you are drawing it, when you're drawing a tetrahedral, it should look like this. Here's my carbon, my hydrogen goes up, just like that lone pair, just like my face was up, and then the rest is a tripod. So that dash that wedge, and that stick. Now, it's always easier if you have to draw 2 central atoms or more than 2 central atoms to have your next central atom be on a stick, not a dash or wedge. Part of the rules about drawing VSEPR shapes is to draw the most simple VSEPR shape. So that keeps it simple, putting that second central atom on a stick. So we're going to put that oxygen on a stick. Now I have to make that oxygen look like a V. So if I put the hydrogen coming down here, that last hydrogen that's attached here, that doesn't look like a V. It looks linear, right? It looks like a straight line. So I'm going to need to draw that V like this. Now this looks like a V. This looks like that 109 degrees that it's, or 104 degrees that it's supposed to look like. Sorry, I should have said 104. Anyway, okay. That's not really what I'm here for. I'm here to help you draw. Okay, so 2 sticks for the bent, and then those 2 lone pairs, which helped push that into the bent shape. You can draw the lone pairs. You don't have to draw the lone pairs. Okay, so 2 tetrahedral shapes here. 2 VSEPR shapes here. One is the tetrahedral on the carbon, and the other is the V on the oxygen. Right, let's talk about HCN. HCN here has just 1 central atom here in the middle that's surrounded by something. It has 2 bonding sites and no lone pairs. And these multiple bonds are considered to be 1 bonding site, right? It's not a bonding electron, it's a bonding site. So this is a bonding site. Here's another bonding site. 2 bonding sites and 0 lone pairs means it's linear. So when you're drawing it as linear, it's just, first of all, it's linear. And when you're drawing it as linear, it's already a line. I don't need to do anything else. This already looks like it's 180 degrees. I don't have to do anything else. This is the VSEPR shape as much as it was the structural diagram. Okay, so hopefully that gives you some idea on 3 of the trickier VSEPR shapes and some of the finer details you need in order to secure the higher marks.